Hi, everybody. I hadn't planned to be absent today, but I am. So I'm making a quick video to talk to you about the 10.3 notes. Okay, so starting in this section, 10.3 through 10.7, everything is kind of together on one formula chart. So if you click right here, you'll see that formula chart. And this is something that you'll want to refer back to again and again because it's got all those formulas that you need. So we're only going to look at these first three sort of formulas, okay? The first one here says that if you have two chords that are congruent, then the arcs that contain them, A, B, and C, D, are also congruent. And so the converse is also true there. If the arcs are congruent, then those chords are congruent, okay? Next, if you have a diameter that intersects with a chord at a 90-degree angle, it's a perpendicular bisector of that chord. So AE is equal to EC, and it also bisects the arc that is contained by that chord. So AB is equal to arc AB is equal to arc BC. Next, you have these two lovely pictures. Basically, what you have here is when you have two chords that are the same distance from, oh, this is, okay, sorry. If you have two chords that are congruent, like PR and ST, then they will be the same distance from the center of the circle. And conversely, if you have two chords that are the same distance from the center of the circle, then those chords are congruent. Okay, so the next thing that I have for you is the circle's notes. So I'm going to leave this open, the circle's formulas, but I'm going to flip over to the camera and try to show you the circle's notes. So what this is applying the formulas that we just saw. So first of all, you have this circle and there are two chords in it. I've got chord AB and chord CB. They tell us that the measure of arc BC is 145. I've written that down, and that AC is 70 degrees. So to find arc AB, you're going to do 360. That's the total in the circle, and subtract the two arcs that you know. Subtract that 145 and subtract that 70. What's left is 145 degrees. So arc AB is congruent to arc BC. Now, because of that first rule that we looked at in those circles notes, because these two arcs are congruent, these two chords are congruent. So arc AB, the measure of AB, is 145 degrees, and chord BC is 8 units, whatever unit of measurement they're looking at there, okay? Next, in this example, you have a diameter that is bisecting a chord. It's intersecting a chord at a 90-degree angle, and therefore these two sections of that chord are congruent, and these two parts of this arc are also congruent because that diameter has bisected them. Now they give us some information up here. They tell us that the diameter of FH is 10. That means that this radius is 5. Right? This radius here is also going to be 5. And the one that goes from F to D is going to be 5. So to solve for B, we're just going to say 5 minus the part we know, which is 3, and that's going to be 2. So B is 2. All right, next, we need to solve for A. A is this section of that chord. It's the same as this section over here. Now you'll notice that we actually have a right triangle here. So to solve for this one, we would do Pythagorean theorem. So you could do Pythagorean theorem here. You could say 5 squared equals, let's call it A. A squared plus 3 squared. But if you remember your Pythagorean triples, you know that 3, 4, 5 makes a right triangle. So 5 squared plus 4 squared equals 4 squared plus 3 squared. Well, that's messy. But basically A equals 4. All right, finally, they're asking for some arcs here. The measure of arc FG, that's this arc here, it's congruent to arc EF. So FG, the measure of arc FG, is equal to 50 degrees because those two are congruent. Next, measure of arc EFH. All right, so E starts here and then F and then all the way to H. So this is a major arc. Now, because this is a diameter, you know that this whole distance from F to H is going to be 180 degrees. So if you needed to mark this section out, this would be 130 because that total here is 180 and that part is 50. So the part that would be remaining is 130. So 130 plus 50 is 230. So the measure of EFH, the arc EFH, is going to be 230 degrees. All right, last example. Now on this one, they are telling us that GF, this whole chord here, is equal to DE, this whole chord here, and they're both 32. So this is 32, and that's also 32. Now, with that third rule that we had on our circles formulas, let me see if I can pop back to it. The third rule says that if you have two chords that are congruent, then the distance from the center of the circle is also congruent. So let me see if we can solve this one. We're first going to solve for x. Now, if these two chords are congruent, then these two segments are also congruent. So we can say that 4x equals 7x minus 9. I'm going to go ahead and subtract 7x on both sides. I end up with negative 3x equals negative 9. Divide both sides by negative 3. And x equals 3. All right, well, that was relatively easy. I'm going to go ahead and plug that back in because I feel like I'm going to need to know it to find the radius of this circle. The radius here, the easiest way to find it is to draw a line from the center of the circle to the circle. And I like this one here because it creates this right triangle. All right, I know you could almost smell the Pythagorean theorem in the air, right? Okay, so we have F over here, B here, and A here. That's the center of our circle. We are looking for our radius. 4x is 4 times 3. That's going to be 12. And remember how we said that this chord was 32 units long? This chord happens to be, because this line comes away from the circle at a 90-degree angle, if we extended that, it would basically become a diameter, right? And the rule over here was when a diameter bisects or intersects a chord at a 90-degree angle, these two segments become equal. That is bisected. So I can say that this side over here is 16. So now we're really going to do Pythagorean theorem. R squared is equal to 16 squared plus 12 squared. So that you do a little bit of multiplying, or we could really derive this, right? So R is equal to the square root of 16 squared plus 12 squared. I don't know it off the top of my head, y'all. 16 squared is 256. And then we're going to need to find the square root of that. So let's go ahead and add it. Plus 144 is 400. Oh, I know this. The square root of 400 is, okay, so R is 20 right there. Okay, those are your 3 example problems. With this and the circles formula chart, you should be able to get to work on those 10.3 practice problems. Have a great day, everybody.